We are going to be looking at an example of using grouped continuous data. Now for continuous data, since you have a wide range of values, you cannot use the actual data points to find the mean, variance, and standard deviation. So we use estimates of those values in order to find those measures of the data. So in order to find the mean, variance, and standard deviation. And we do that by assuming that all of the data points are equally spread around 1, and that is equally spread around the midpoint. So in order to find these estimates, we would be using the midpoint of each group. We can also find the modal class. Now remember, the modal class is the group with the highest frequency. And we can do that if the data is arranged in intervals of equal width. Right? So we're going to be doing this example from your textbook, where we're using heights of 200 fir trees to determine some values. So we have heights in groups from 0 to 1 meter, 1 to 2, 2 to 3, 3 to 4, 4 to 6, and 6 to 10. So we're going to find estimates for the mean and standard deviation. So again, in order to find these estimates, we need the midpoint of these values. So we're going to be finding the midpoint of the interval. So from 0 to 1, so adding them together, dividing by 2, from 1 to 2, and so on. From 2 to 3, 3 to 4, 4 to 6, oops, and then 6 to 10. So these are the values that we're actually going to have in our spreadsheet when we're finding the mean and standard deviation. So we're not using the values in our table because we actually don't know. We know that 17 of them are from 0 to 1 meter, but we don't actually know how many are 0 meters or 0.5, 0.75, whatever. We don't know how many are in each actual value. And there's so many between 0 and 1, so many different heights, that we have to use the midpoint as an estimate. So once we have these values, we're actually going to be using our graphing calculator. So I already have a list and spreadsheet open with my columns named. So one column is height and one is frequency. So I'm going to use the midpoints that we just found as our height, and then the frequency as the frequency. So in this box, I'm going to have 0.5, and 17 is our frequency. And then we have 1.5 and 35, 2.5 and 69, 3.5 and 51, 5 and 22, and then 8 and 6. So when we're finding the mean and standard deviation, we would do this the same way as we would if we just had a list of a bunch of different values, if we had discrete values. So I'm going to go to Menu, Statistics, Stat Calculations, and One Variable Statistics. I still have one list of actual variables. The frequencies here are not the variables. The only variable we're considering is height. So I still only have one list. My list is titled height, and now I'm going to be changing my frequency list. I no longer only have one value for each of those different heights. I have the frequencies labeled in the column that's labeled frequency. So now my calculator is going to say, oh, okay, well, we have 17 value, or 17, 0.5, and so on. So I'm going to hit OK, and I'm going to get all of these values. Now remember, X bar here is the mean. So our mean is 2.85. And then standard deviation is sigma, which is 1.4975, or 1.5. So again, mean is 2.85. Mean X bar is 2.85. And then our standard deviation was 1.5 when we rounded to 3 significant figures. So these two are our answers to part A. Part B is asking why these calculations for the mean and standard deviation are estimates. Now remember, we used the midpoint of each of these classes as the data value we inputted into our calculator. So since we use the midpoint, we're using the midpoint as estimates of what the data values actually were in each of these classes. We don't know what they were. So we're using the midpoint as an estimate for those data values, which means the mean and standard deviation we got are also estimates of this data set.